All right, this first free response question is actually very similar to the one that we had before for the honors practice test. I just wanted to emphasize how to do it. So just to be clear, again, remember we've got normal force, we've got weight, and we've got tension acting on big M. And since the forces aren't balanced, we're going to get that the tension makes the big mass accelerate, and that the normal is going to balance the weight on big M. Now for little m, we're going to have the tension pointing up and we're going to have the weight of little m pointing down. And that equation is going to look like little mg, which is its weight, minus the tension makes little m accelerate. And now we can go ahead and put in numbers. So what's going to matter for this problem, we're going to get tension is 4 times A, 1 times 10 for gravity, 1 being the mass, 10 being the gravitational strength, minus the tension equals 1 times A, so we're going to get 10 minus T equals 1A. And we can actually go ahead, I'm not going to work out all the math because I did it in a previous video, but what we're going to end up actually getting is that the acceleration is 2 meters per second squared when we combine these equations, and the tension is going to be 8 newtons. Now, we want to ask what would the coefficient of friction be if the block accelerates at 1 meters per second squared. So this is actually going to require a slightly different set of free body diagrams, which we can actually put right here. So with this in mind, we're actually going to have slightly different equations, in fact. We're going to have a friction force acting here. So actually, our equation needs to be modified to tension minus friction equals m times A. And this equation here, though, stays the same. Now, one thing is we actually need to get some numbers in here. So we know the tension, it is not 8 newtons anymore. We need to recalculate that. Minus the unknown friction is going to be equal to ma. Now, our friction is going to be mu times the normal force, and that's going to equal 4, the mass, times A. Now, we got that the normal force actually equals the weight, so that's going to be 4, which is the mass, times 10, which is 40. So our equation that we end up with here is a little bit different. It's going to be T minus mu times 40 equals 4 times A. And we can't do anything more with that. Now we need to go to our second equation. It's going to actually look very much like it did in the previous part. 10 minus T equals 1 times A. And now we have two equations, and actually we have one more known quantity, which is we know the acceleration is 1, so we can put that in there right here. So now let's go ahead, now that we've got our equations, let's go ahead and actually try to solve. So we have 10 minus T equals 1 times 1, and we're going to actually have one more equation, which is this one here, which is T minus mu times 40 equals 4 times A. Now let's rewrite this just a little bit differently. I'm going to write this as negative T plus 10 equals 1, and here I'm going to write this as T plus mu times 40 equals 4, because A is 1. Now I can actually add these two equations together, and that's going to give me 0 plus 10 minus 40 mu equals 5. And when I combine here, I'm going to get 40 mu equals 5. When I rearrange this equation, I'm going to get mu is actually 5 over 40, which ends up being 1/8 when I go ahead and solve. So that is the coefficient of friction needed to give me an acceleration of 1 meters per second squared.